Hello everyone, welcome back to my channel. Today we have this Dell Optiplex 3050. This one does work actually, but it immediately shuts down. Let me connect the power cord and try and replicate the problem before doing anything. Here is the power cord. Okay, let's turn on. The power is on. As you can see, it does turn on. And this is normal for Dell computers. As you turn on the power, they turn on for a couple of seconds and then they go back off. So this is normal. So let's try and now press the power button. Let me take this front cover. Okay, let's turn on. As you can see, it does turn on, but immediately shuts down. Let's try it again. Again, doing exactly the same thing. And the power button, let's check the power button if we have any fault codes. So we have the yellow light, and then it turns off with no fault codes. Okay, the first thing we do is check the connection. If anything that is not connected properly or is connected in a wrong position, wrong connector. So here we have everything seems to be good. Let's try and take the BIOS battery to reset the BIOS. Okay. I am shorting the battery terminals to discharge any remaining voltage. So let's put the battery back again. Okay, let's turn it on again. The power is turned on. So let's wait for it to cycle on and off. Okay, there we go. Let's try and turn it on. It does turn on, but immediately shuts down. Let's turn off again. Let me take the RAM models. Without them, let's check if we will get any fault codes, any beeps. Okay, let's turn it on. Nothing, exactly the same, so it is not a RAM issue. And here is the power button, exactly doing the same. Okay, what we will do now is I can take the heatsink and inspect the CPU pins, but first let's check if we do have the correct voltages on the coils. So we have 3.3 volts, we have 1.2 volts for the RAM memories, we have 0.9 volt VCCSA and VCCIO, and also we need to check the VCore voltage. So let's check. Let me bring the multimeter leads. Okay, so let's put this black probe in a ground, in any ground let's use the USB. Okay, so let's check first this coil. For example, here we have 0.9 of a volt without turning it on. Let's turn it on. It goes to 1 volt, so it looks good, this coil. What about this one? This one has 3.3 volts, as you can see. Okay, here is another coil. This one have 5 volts. Yeah, we have 5 volts. Here we have another coil. Okay, so this coil has nothing. Let's turn on. Yeah, we have 1.2 volts, which is RAM memory voltage. So everything from this side, all these coils looks good. Let's check the VCore. So before the VCore we have 12 volts, which is right. So VCore should be around 1 volt, 1.2 volts. The VCore is missing actually. We have no VCore voltage. That's why maybe it is not turning on. We have here another 2 coils. Maybe this one is the VCCSA and this one VCCIO, I think. So this one has 0. When we turn on, goes to 0.9, which is good. So this is, yeah, the VCCSA, I think. So let's check the one next to it, which should be the VCCIO. And this one has no voltage. No voltage even when we turn on. As you can see, it's 0. So this might be the problem actually. This might be the problem. Let's go under the microscope and check that power supply. Okay, microscope. So these are the 2 coils that I was just checking. This is the VCCSA and this is the VCCIO. I think, I'm not sure, but they might be. So let's check. This one is good, we said it's good. This one is, I think this resistor is not good. What is this? This resistor is not good. Let's check the voltage here. When we turn on, so here we have 0, and when we check here, let's turn on again, we have 5 volts here. So yeah, this resistor is not good. Let me zoom in a little bit. Let me zoom in a little bit. So it's a 2.2 ohms resistor, and it looks burned actually. It looks burnt, yeah. Let's turn off the power. Let's go to ohms. I want the, let's measure it. So it reads 157.9 ohms, which should be 2.2 ohms. So why this resistor got burnt? So do we have a short here after it? We have 1.8 ohms to ground. So there is a short actually here. It's not complete short to ground, but it is very low, 1.5 ohms. From this side, it should be the resistance of this resistor. So it's 194. This resistor now reads 203 ohms. Okay, let's check the other power supply, which is this one. So again, exactly the same layout. Here we have the 2.2 ohms resistor. It reads 2.2, yeah. So let's check to ground. 5 mega to ground. 5 mega ohms. And the other side should be the same because it's just 2.2. Yeah, exactly the same. So this resistor got burnt because of the short after the resistor. So we need to check what is causing this short. So this resistor actually goes to this capacitor, and from this cap also goes to this chip here. So let's check. Maybe we have this capacitor faulty, partially shorted. I can see it discolored. It's different from this one. Okay. So this capacitor might be shorted actually. I want to inject a little bit of voltage there and check it with my thermal camera. Let's go to main camera, and this is the ground of my power supply. So I will put the power supply to, let's say, 0.9 volts. Let's check the current. We have 3 amps. I think it's good. I will inject voltage after the resistor and see what gets hot. Is it the capacitor or the IC, the chip? Oh, so it's drawing only 0.12 of an amp, so 120 amps. I think I need to raise a little bit the voltage, because this line should be 5 volts. You remember we find 5 volts before that resistor. So I'll raise it to, let's say, 1.2 volts. It's taking 400 milliamps. I can't see what's getting hot there. Let's use the microscope, and I will use a little bit of alcohol there. Okay, let's inject now. Yeah, it's the capacitor actually. It's this capacitor. Let's do it again. As you can see, that capacitor let's do it again. As you can see, yeah, that capacitor is bubbling. Let's wait for it. It should dry out. I think it's already dried. Let's turn off this light. Okay. Let's do it again. Yeah, exactly that capacitor. So we need to take out that capacitor and we need to change that resistor, which is 2.2 ohms. I need to protect this capacitor here because it's really next to it. Okay. And also we need to take off this plastic. Let me go to the camera. So we have here a plastic here. This is the connector that goes out for the VGA. Okay, so we need to take out that capacitor now and replace that resistor. I will use one of these heat gun nozzles to protect this capacitor. Yeah, like this. I might use the microscope for a better view. Okay, so here is the capacitor and the resistor. Let's take them out. Okay, so they are both out. Okay, so I have just replaced these two components, the 2.2R resistor and the capacitor. The capacitor, I measured the one next to it and it turned to be around 1 microfarad, so I replaced it with 1 microfarad capacitor. Okay, let's go back to the main camera. Let me clean a little bit. Okay, I think we are now ready to test. It's cold enough. Now I will use the HDMI. Okay, it's connected. Let me bring the microscope view so you can see if it does work. Okay, this is the microscope view, as you can see. And now let's try it. Everything is good. The power is turned on. As you can see, it cycles on and off. And now it comes on by itself actually. Let's wait if we will get a display. change the mode. Yeah, what is happening? Why the fans go crazy? Maybe because we reset the BIOS. Let's wait for it. And yes, we have a display. Yes, we have a display. So yeah, that was the issue. Let's check that coil again now. How much voltage does it have? This coil has 1 volt, yeah. So this is the VCCIO, and this one is the VCCSA. And as you can see, let me go to 3 so you can see it better. So it says support assist detected a high system temperature. Ensure all cooling vents are clear of obstructions and uncovered when in use. Previous desktop thermal failure alert. Previous shutdown due to thermal event. Let me connect the mouse and press OK. Okay. No bootable device is found, so that screen or that alert from before is not present any longer. So we have only this no bootable device found. So now the computer seems to be good. Let me put I will shut it down. Let me connect a hard drive and see if it will load the Windows. Okay, here is a hard drive with Windows 10. I will hold it like that. Let me connect back the mouse. Okay, let's turn on. Alert keyboard is not found. Yes, it is. I did not connect the keyboard. Want to see it loading the Windows? And yes, it is loading the Windows. So everything seems to be good. Everything seems to be good. And as you can see, it loaded the Windows successfully. And yeah, as you can see, it does work. Everything is just fine. Okay, so as you saw, one of the things that prevents the VCore from being issued, from appearing, is the VCCIO. Previously, I fixed on a Lenovo desktops, the VCCSA was failing, and I fixed the VCCSA, and the VCore appeared immediately, and we have display. This time we have VCCIO, which caused the problem, exactly the same problem. The VCore is missing. All other voltages are present and correct except for the VCore, and it is because of the VCCIO. Okay, so thank you for watching. I hope I can see you in another video. If you like this video, please don't forget to like, share and subscribe to my channel. Thank you for watching and see you in another video.